Hello, welcome. We are going to look at another application of locus or loci or loci, so to speak. And in this case, we are going to draw what we refer to as Archimedean spiral. Archimedean spiral is a locus, and it's a locus of a point that moves away from a fixed point with a constant speed along a line that rotates with an angular velocity. What we need to understand when you talk about that locus of a point moving away from a fixed point with a constant velocity, this is what we imply. Like for example, if this is point, what we are referring to as the fixed point, and there is another point that is moving away from this fixed point with some angular velocity, it means it's going to rotate in that manner as it moves away. So that is a point that's taking that pattern and it's moving away from a fixed point. So this is a spiral, and we're referring to it as Archimedean spiral. How do you get to draw this? We are going to draw it by use of this question here. The question reads, draw a spiral of one convolution. Draw a spiral of one convolution. Point O moves away from the pole and reaches a distance of 45 millimeters. So what we got to do is, first of all, we draw a circle equivalent to the of radius 45. That is a radius of radius, a circle of radius 45. Then from there we shall see how to draw that particular Archimedean spiral. So having that straight line, we can start here, or this center point, we are referring to it as a pole. It is a pole where, or a fixed point where the point P is moving away from. Now next is we are going to indicate this one as point P. It has moved one spiral or one convolution from O. It has moved away and reached there. So the next step we shall do here is we are going to divide that circle. Of course, it's radius 45. We are going to divide it into 12 equal parts. So we can come here and divide. First of all, let's draw our other center line. Then we divide it into 12. Now to divide a circle into 12 parts, we first of all need the radius. Stand with it at every point of intersection between the center lines and the circumference and make those arcs in that manner. Okay, then we join the points. You join the points. Once you have joined, we can name them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we are going to call this one O, the pole, or then we divide OP again into 12 equal parts. We are going to divide OP into 12 equal parts. How do you divide into 12 equal parts? We can have another straight line from here, from the center point. Then along that line we get 12 divisions. Let me extend it. Along that line we get 12 divisions. And talk of 1, 2, 3, 4, 5. Sorry for the blurring. 6. This is 10, 11, lastly 12. Then we join the last mark to the last point. From this point P, we can join, then transfer the other points. Can transfer them, and let's say here we are going to transfer these other points to our line OP. So we realign, then we hold firmly, maybe on this side. So we move. First one moves there, second, third, fourth, that order, just move one by one. And then lastly, so those divisions are 12. We can name them or number them as 1, 2, 3, in that order, okay? 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the next thing we are going to do is we are going to draw an arc from 0 to number 1. We first of all get to take 0 to 1 and draw an arc to meet line 1. It stops there. Next, we take 2 from 0 or from the point O, then draw an arc to meet line 2. Next, to 3, draw an arc to meet line 3. Next, to 4, draw an arc to meet line 4. Line 4. Next, 5, draw an arc to meet line 5. Next, 6, and of course 8 here, an arc to meet line 8. Then 9, the circles are going to be more small and small and small, so you need to be very careful so that you don't mess up. This is 9, so we are looking for 9. There is 9. Next is 10. So that's how those points have met the lines, and how those curves have met the lines. So we are going to draw a curve right away from this point P, pass through this point, pass through here, 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 as you can see, here, here, this point, this point. In that manner, so that it's going to assume that shape that we are referring to as a spiral. So as you can see, it's coming right away from O and it moves away in that spiral manner. And lastly, so that is how we get to draw what we are referring to as Archimedean spiral. Thank you very much for attending to my lesson. Consider subscribing, share out with your friends, your colleagues, and anyone you feel will benefit from this. Have a nice time.